Welcome back to my channel. So in this video we will continue about the differentiations on the topic of equation of straight lines. So before we enter the curve, we must learn the straight line first. So here is such basics. So we know that first one, the gradient or slope is m, where we call the symbol m is known as dy dx. It's the differentiate, and we know that when we find the dy dx, we are actually finding the gradient of tangent. So, and we know that for the equation of straight line, we can use y equals to mx plus c, or we just use this. This one is now more mature. Y equals to y1 equals to m x minus x1, where y1 and x1 is a random points on curve. Alright, so if you have 2 points on the curve x1, y1 and x2, y2, you can actually derive this formula from here to here, since we know that m equals to y2 minus y1 or x2 minus x1. So when we find the slopes, we can actually calculate and we put here x minus x1 to the left hand side, and we can get these equations. So in STPM, we can straight away use the both formula to find the equation of the straight line. So yeah, so in STPM, they usually ask the equation of tangent and the equation of normal. So what is equation of tangent? Let's say if you have a curve here, I really draw nicely. So, and tangent, what is tangent? Tangent is such a line that touch a point, a single point on the curve, and it's a straight line, and it's only touched once and never touch really. Alright, so normal is the perpendicular line to the tangent, or we known as the reciprocal to the tangent lines. As you can see, the gradient of tangent is only touching a random point on the curve, a specific point I can say, so it's dy dx. So gradient of normal is actually d squared y dx squared. Here is the gradient, or we known as m. Alright, so but I would like to tell you, if you find the d squared y dx squared is a second derivative, but however, if you do the second derivative, it will take a lot of time. So I suggest you to use the shortcut, where the perpendicular of tangent normal. Since we know that tangent and normal is actually perpendicular to each other, hence we can imply the implications of gradient of the tangent or normal equals to reciprocal -1 of the m of the gradient or slope of the tangent and normal. So they are actually reciprocal to each others, and you put here, so you get here is tangent or normal, and here is vice versa. So and we will get m1 m2 equals -1 indication. So we only need to find the equation of tangent, gradient of the tangent, and hence we can deduce the gradient of the normal. Yeah, let's say I have the gradient of tangent. Let's say this is gradient of tangent is -8/7. So when I want to change it to the gradient of normal, I just need to reciprocate it 10 times with a -1. So what will I get? So I will get -1 over -8/7, and I will get 7/8. Here is my gradient of normal, and we substitute inside the equation y minus y1 equals to m x minus x1, and we substitute here, we will get the equation of normal. So alright, so let's see some examples. So find the equation of tangent and normal to the curve x squared y plus xy squared equals to 12 at the point of 1, -4. So how are we going to solve this question? So first, of course, we will copy down. I will copy down the equations xy squared equals to 12. So we want to find the equation of tangent. So what we must have? We know that equation of tangent is a straight line, right? So it's a straight line equation. So we will use y minus y1 equals to m x2. It's x minus x1. So now we need to find. We already have the point given. Here is the x1 and here is the y1, right? So now we need to find the gradient. Gradient of tangent, how we find it is actually dy over dx for gradient of tangent. So now we just differentiate things, all the things, with respect to x. So you get here we must imply the product rules. Hope you all still remember. So x squared dy dx, I put a bracket, plus product rule is plus, and y times 2x and plus. Now product rule, I have some shortcut, as you can remember. So we copy the first one, we differentiate the second one, get 2y. dy dx, don't forget the dy dx here since we are differentiating y with respect to x. And we plus y squared 1. Yeah, right? So yeah, now we're getting the answer, and here when we differentiate the constant we get 0. Here is implicit differentiation actually. So we factorize the dy dx, we will get x squared plus 2xy dy dx, and here is, I put a negative y squared here, so it will be negative y squared, and here we got the 2xy, so it's minus 2xy. So we put everything else except dy dx to the right hand side, so we will get negative y squared minus 2xy x squared plus 2xy. So here is the gradient of tangent. I really show you the gradient of tangent. So now we have the y1, we have the x1 ready, so I have the m ready, so I can straight away deduce the equation of tangent now. So equation of tangent, I prefer you to, you may at point, so you can get some marks if you are wrong in the down. At point negative 1, no sorry, it's 1, right? Yeah, it's 1. 1 negative 4, so you can calculate the dy dx equivalence to negative, so it's negative 4 square minus 2 1 negative 4 1 square plus 2 1 negative 4, and we calculate, you should get the answer, 8/7. So here is the gradient of tangent at the point 1 negative 4. Means that we have a curve, so at this point, let's say it's 1 negative 4. At this point, we have tangent. Oh, sorry, it just supposed to be touched only 1 point. And here the tangent will have the gradient of 8/7. So to deduce the equation of tangent at point 1 negative 4, so we will get one answer. So we will get y minus 4. As I substituted the equation, y minus y1 equals to mx minus x1, so you can see the y1 is negative 4, right? And equals to 8/7, x is minus here is 1 and 1, and we get answer will be, I put this on the left hand side, and I will get 7y minus 8x equals to negative 36. Here is the final answer. You can try to do it. Alright. So how are we going to find the equation of normal? How are we going to find? The equation of normal? Are you going to do the d squared y dx squared from here? I don't think so. You can see the dy dx is already so complicated. If you want to do the second derivative, I can say it's not wrong, but it's too long and too wasting of time. So I will just suggest you, since you already have the gradient of tangent, here is the gradient of tangent, it's 8/7 at the point 1 negative 4. I say gradient of tangent and gradient of normal, they are actually reciprocal to each other. So you know that m1 dot m2 or m1 times m2 equals to negative 1. So now if you want to find the gradient of normal, you negative 1, you can put the gradient of tangent to the reciprocal here, and you will get negative 7/8. Here is the gradient of normal. You just use the negative 1 divided by the gradient of tangent, you will get the gradient of normal. So now you have the gradient of normal, you have the point 1 negative 4, so you can find the equation of normal at point 1 negative 4, and you will get the answer. You just substitute inside the equation y minus y1 equals to mx minus x1. So now you have everything. You can substitute y minus 4 equals to negative 7/8 x minus 1, and at the end you will get the answer 7x plus 8y plus 25 equals to 0. Alright, so here is how we solve the equation of tangent and equation of normal, just using the shortcut of m1 m2 equals to negative 1, because since the tangent and normal are actually reciprocal to each other. So the next question, let's see a past year question. It's STPN 2014, and a curve is defined as the parametric equations. I will say this equation is quite important. This question is quite important for you to understanding. defined by the parametric equation where x equals to 1 minus 2t, y equals to negative 2 plus 2 over t. Find the equation of the normal, you can see, to the curve at the point of specific point. So here is one part. So the normal of the curve at the points cut the curve again. So here is the tricky part. The normal of the curve cuts the curve again at the point B. So find the coordinates of point B. So here's quite interesting questions, I can say. So how are we going to solve this? So we are solving the first part of the question first. Each one is define a parameter. We need to find the equation for normal using the parametric equation. So I already talked at last video. So we just copy back. Using the chain rule, and we can find the dy dx. And yeah, so with dx over dt, we will get negative 2. Whereas here, yeah, if you want to simplify it, you can just like here plus 2t to the power of negative 1. Yeah, right. So here dy dt will be equivalent to negative t over t squared. Alright, so because here we differentiate constant, we get 0, right? So dy dx, as I said, as we using the chain rule, we use dy dt divided by dx over dt. And negative t2 square, and here is negative 2, and we get 1 over t square. So here is the gradient of tangent. Don't forget, this is gradient for tangent. It's not for normal, since the question wants us to find the normal. And hence, we can deduce the gradient of normal by using the relationship m1, m2, or m to the normal and n to the tangent equals negative 1. So we know that gradient of normal, m normal, is equivalent to negative 1 over 1 over t squared, and we get negative t squared. Here is the gradient of a normal. So now, here is the point. At point A is negative 3, 4. At point 3, negative 4 is 3, negative 4, right? And negative 3, 4 or 3, negative 4. I'm sorry, here the question should be 3, and here is negative 4, right? So at point 3 to negative 4, x equals to 1 minus 2t. We have the x minus 2t, right? So we can using both of these, but of course I will choose here because here is much easier. So x equals to 1 minus 2t, we can deduce the 3. We want the, yeah, and we get t equals to negative 1. You can substitute using the y equals to negative 2 plus 2 over t also, but I will choose the easier one, so I get the t value. So I get the t value, I can know the I gradient. I have the value for the gradient, so the normal will be equivalent to negative 1. Right? Okay, no, sorry. It's supposed to be negative 1 square, and we get back negative 1. So now we are finding the equation of normal at point A. So just use back the equation y minus y1 equals to m x minus x1. So now we have y minus 4 and equals to negative 1 x minus 3, and we get y equals to negative x minus 1. Alright, so here is the first part of the fractions. Now we are going to the second part of the fractions, which the normal to the curve at the point cuts the curve again at point B. So we need to find the coordinates of point B. So how are we going to do that? Yeah, such interesting. So yeah, I will show you. So let's say I have a curve. Here is y, here is x. Alright, so now I have a curve here. Let's say. So now I have here, you know, I have a normal. Here is my tangent, right? I have a tangent. Then I have a normal here, which is perpendicular to the tangent, and I actually cut the 2 points. So I will cut the first point, of course, at the point A, which is 3, negative 4. And I will cut also the point B. As you can see, the normal actually cutting 2 points. The tangent, here is the tangent, and here is the normal. So I'm cutting 2 points. So what my normal equation is given by y equals to negative x minus 1. Yeah, so you can see what is this relationship. This is actually the intersecting point, right? Yeah, so it's an intersecting point between the curve and the normal line. Intersections point between the curve what is the curve? Yeah, it's given, right? I think the curve is given, yeah. So the curve equation is already given. You can find the equation of curve and the normal line. So what is the equation of curve? It's actually y equals to -2 plus 2 over t. Actually, the curve you can use x equals to 1 minus 2t. It will be the same answer, yeah. As you have now, you have, yeah. So I will use for intersection point. Point B is actually the intersection point B, and now is -x minus 1 equals to -2 plus 2 over t. Since I have the y, so I just balance the y. So just now we can substitute that x equals to 2. I move x to the right hand side and move everything else to the left hand side. So I will get 2 over t minus 1. So I will get 1 minus 2 over t. So now I have this equation x. So what I'm gonna do will be very, very specific now. When I have x equals to 1 minus 2 over t, it's actually equals to the 1 minus 2t. This is how can we find the intersecting point, 1 minus 2t. Yeah. So we can get the 2t equals to 2 over t, and we get 2t squared equals to 2, where t squared equals to 1. Hence, we know that t equals to 1 or t equals to -1. So when t equals to -1, we can see here already we define the t equals to -1, right? Yeah, t equals to -1. At point 3, -4, t is -1. So here is the intersecting for point A, so rejected since for point A. So here is the t for the point B. I hope you all understand. Here is the parameter for point B. So while we have the t for the point B, and we can find the coordinate B when t equals to 1. So by using the parametric equation, we can find x equals to 1 minus 2t, and equals to 1 minus 2, 1, and we get -1, where y equals to -2 plus 2, 1, and we get 0. So the point B is actually -1, 0. So here how we find the intersecting point of point B. So here is the answer. So how we're gonna do the intersecting part by balance two equations. Since we have the y equals to -x minus 1, since we balance with the parametric equation. I know it's quite new, but we need to balance the x, and we found the x in terms of t. Then we balance the x again with the parametric equation. Means that we are balancing 2 times actually. But you can also find t here, and you substitute into the y, and actually it's the same thing, right? Not only now the problem is we just balancing the given equation with 2 parametric equations, or you can just solve like that. Yeah, you can just solve t here. Your t is actually, you get 1 minus 2t equals to x, and you put you get 2t equals to 1 minus x, and t equals to 1 minus x over 2. And hence you can substitute the t inside here, and you get the equation of y equals to something x, and hence you can straight away balance with the equation here, and hence you no need to balancing 2 times again here. So it's actually the same thing, right? Alright, I think here is the end of the videos, and next I will talk about the curve, about the stationary point, turning point, maximum point, minimum point, and point of inflections. So I hope I can see you in the next video. If any mistaken, you can leave in the comment box. Okay, see you again. Thank you for watching.